Hi class, today's lesson is lesson 4-7. It's on comparing and ordering fractions. Our purpose for today is to compare and order fractions. We have three terms which we need to go ahead and define, so I want you to go ahead and turn to the back of your composition books and record these terms and their definitions. First term is like fractions. Like fractions are fractions in which the denominators are the same. Please write down these examples too. Here we have 2/3 and 1/3. Notice that the denominators are threes or thirds. These are like fractions. The second term is unlike fractions. Now, as you can guess, these are fractions in which the denominators are different. Here we have 1/2 and 1/3. We can see the denominator of a 2 is different from the denominator of a 3. The last term we have is common denominators. This is where we rename two or more fractions so that they have the same denominators. And we'll actually look at this in the next two examples. So first example we're going to do is comparing fractions. Here we're going to compare, write a less than, greater than, or equal sign. And we're going to use pictures or find common denominators in order to find the solution. So first of all, we're going to go ahead and use a picture. Here we have 1/8, and I'm going to note that with an X in this slice, 1 out of 8 slices. Here we have 5/8, and I'm going to note 5 of these 8 slices. Which is bigger? Well, of course, the 5/8 is, so we're going to go ahead and put 1/8 is less than 5/8. Next, we're going to take the B problem, do the same thing, and go a step further with it. First, we're going to use pictures. Here we have 7/10, and we have a square that's divided into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slices. We're going to go ahead and shade in, or in this case I'm going to X in 7 of those 10 slices or pieces, and that gives us 7/10. Next, I'm going to take a look at 1/2. 1/2 would be half of this square. So I'm going to shade everything or X everything up to that line, which is the halfway point. So that'd be 5/10. So we look at the scope of this particular shape or area, and we look at this, and we can see there's a notable difference. This 7/10 is larger than 1/2. I'm going to go ahead and put a greater than sign. Now, there's another way in which we can determine whether or not 7/10 is bigger, smaller, or equal to 1/2, and that's using common denominators, that term we just defined in the back of our book. So I'm going to go ahead and do it with common denominators. What I'm going to do here is I'm going to say, let's go ahead and get a common denominator. Well, how do we get a common denominator? A common denominator means this time I'm going to multiply these denominators together. 10 times 2, which equals 20. Okay? So what does that 20 mean? 20 is going to be my denominator now for both of these fractions. So all I did was I took the 10 and multiplied it by the 2 to find a common denominator. Now, in order to get from the 10 to the 20, I multiplied by 2, of course. That means I multiply by 2 at the top. Because I'm multiplying by 2 over 2, it's just like multiplying by 1. When I multiply 7 by 2, I get 14. So 14/20 is the same thing as 7/10. I'm going to do the same for a 1/2. I multiply 2 times 10. That gives me 20. So I need to multiply times 10 up here. And 1 times 10 is 10, of course. So now, well, 10 over 10, of course, is 1. That's why we can multiply it, because 1/2 times 1 is itself a value equivalent to itself, and 7/10 times 1 is a value equivalent to itself. So here we have equivalent fractions with common denominators. Which one is bigger? Well, it looks like 14/20 is bigger, therefore 7/10 is bigger. Moving on to a little bit more complex comparing. We're ordering these mixed numbers now. It says order from least to greatest. We have 1 2/3, 1 1/2, 1 1/6. Now we're going to use a number line to look at this, as well as look at common denominators. Now I know that the 1 2/3, 1 1/2, and 1 1/6 all have 1s. So those are all the same, and I know they're essentially going to be on this side of this number line. They're going to be greater than 1. Now we've got to figure out if 2/3 and where 2/3, 1/2, and 1/6 come into play. Well, I'm going to compare two of them first. So how do I do that? Well, I'm going to compare 2/3 and 1/2. And just like the last example, I'm just simply going to multiply the denominator. So this is what I'm thinking. 2 times 3 equals 6. So I'm going to convert these into sixths. How do I do that? Well, in order to get sixths, I'm multiplying this by 2 and multiplying this by 2. So I actually have 2 over 2. 3 times 2 is 6. 2 times 2 is 4. So 1 2/3 is actually 1 4/6. How about 1/2? Well, if we multiply that by 3, we get sixths. So we need to multiply the top by 3, or 3 over 3. 1 times 3 is 3. Now we can see that we have 1 4/6 and 1 3/6. And we know that 1 3/6 is going to be the first, and then this would be the last. Well, now we have to throw in this 1 1/6. This we don't need to change. Why? Because the denominators are already in sixths. So here we have 1 4/6, 1 3/6, and 1 1/6. What do? Well, 1 1/6 obviously goes first. So 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. So here's 1 1/6. Where's 1 3/6, or 1 1/2? 1 3/6 is right here. That's actually known as 1 1/2 from the original problem. And then we have 1 4/6. Well, 1 4/6 is right here, which originally is the 1 2/3. So the order that we have is 1 1/6, 1 1/2, then 1 2/3 from the original problem. Least to greatest. Oops, just pass to complete the problem. Now you're tasked with going in and comparing the fractions simply. It says compare the fractions, multiply denominators to find common denominators, then place it on the number line. So you're going to have to draw this number line and then place 2/5, 1/4 on this number line, 2/3 and 1/6 on this number line. So you're using two things. You're using the number line to go ahead and compare, and you're also using the multiplying of denominators to compare. All right, we'll see you in class.